Hey guys, Mrs. Bukaki here. For this video we're going to look at 2x2 matrices and their inverses, and this is from section 4.5. Okay, so a couple new definitions here. A multiplicative identity matrix is basically where the ones line up diagonally and everything else is a zero. So we're looking at a 2x2 matrix. The ones are diagonal, zeros everywhere else, and it's denoted with an I for identity matrix. Basically what that means, if the product of two matrices are inverses, then it will look like the identity matrix. So if two 2x2 matrices are inverses of each other, it'll look like this, the product of that. Okay, so now remember, what is an inverse? Well, for example, if I have 1/4, what is the inverse of 1/4? It's just 4, right? When you multiply them together, you get 1. It's kind of the same concept, only we're dealing with matrices here. So let's start with an example. Okay, so I want to verify that two matrices are inverses of each other. So I have a matrix A here, a matrix B here. They're both 2x2. So their middle numbers match up. That means we can multiply them together. So let's start. I'll use a different color here. First, let's look at row 1 and column 1. Okay, so I'm going to have 2 times 2, which is 4, plus, or in this case minus, 3 times negative 1. I'm going to have first row again, second column, 2 times negative 3, and 3 times 2. Okay, looking at the second row, first column, 1 times 2, and I have a 2 times a negative 2. Second row, second column, 1 times a negative 3, and 2 times 2. It's a plus 4. Okay, so will we get an identity matrix out of this? Let's take a look. When we add them, I have 1, 0, 0, and 1. Okay, so yes, in this case, they are inverses. Let's try another one. I have two matrices here. Again, they're both 2x2. That's what we're working with today. So I know I can multiply them together. And I'm going to start with row 1, column 1. Negative 2 times negative 8 is 16. Negative 5 times 3 is 15. Row 1, column 2, I have a negative 10 and a plus 10. Row 2, column 1, I have a 24 and a minus 24. And then row 2, column 2, I have, negative 15 plus 16. Are these two matrices inverses of each other? It looks like they're going to be. Yes. So let's do another example on finding an inverse matrix. So I'm actually finding the matrix that makes the first matrix an inverse. Okay, so I have matrix A, and this is kind of just the general way of matrix A is set up. So I have A, B, C, and D, which can be any numbers or variables. Now some things to make note of. If the determinant of A equals 0, there will not be an inverse to the matrix. Okay, so in some previous videos, we found how to define a determinant, and that is multiplying A times D minus C times B. A times D minus C times B. Okay, so if the determinant A does not equal 0, then we can find the inverse of it. And this is the general formula here. A raised to the negative first power means inverse. So the inverse of A equals the 1 over the determinant times this new matrix here. Now remember, we had our original matrix is in this format, A, B, C, D. Now we switched some things around. So I switched the places of A and D. Now D is first. And then the other change I made was to switch the signs of B and C. Okay, that's how you find the inverse matrix. Okay, 1 over the determinant times, switch places with A and D, and change the sign of B and C. Okay, so let's try an example. Here's a matrix M. Oh, I didn't mean to do that. Matrix M, and the first thing we need to do is find its determinant. If it does not equal 0, we can continue. So I look at A and D and multiply them together, which is 8 minus C and B, or I'm sorry, B and C. Okay, A and D minus B and C. Okay, so this is minus 10, and that's negative 2. So we can continue. This is our determinant. I'm going to abbreviate it. So the process, I'll scroll back up. This is the formula we want to use. Okay? So we have 1 over our determinant, or negative 2, times, switch places. So I have negative 4, negative 2, and then change the signs of B and C, negative 2, negative 5. So you can see the difference here. Switch places here, which I did, and switch the signs here, which we did also. So now let's multiply. So you can think of this as like dividing by a negative 2. So negative 4 divided by negative 2 is just 2. Negative 2 divided by negative 2 is 1. Negative 5 divided by negative 2 is 5 halves. And negative 2 divided by negative 2 is 1 again. Okay, so this is our inverse matrix. And to check our answer, I can multiply it by our original matrix. And if we get that identity matrix, then we are correct. So let's do that real quick. I'll rewrite this. I have, let's see, negative 2, 2, 5, negative 4, and that's M. And my new matrix, which is the inverse of M, is equal to 2, 1, 5 halves, and 1. Let's multiply these two together. I'll rewrite it. Negative 2, 2, 5, negative 4, times 2, 1, 5 halves, and 1. Okay. Negative 2 times 2 is negative 4. 2 times 5 halves, the 2's cancel, so you're left with plus 5. Negative 2 times 1 is negative 2. 2 times 1 is 2. Come to my second row, I have 5 times 2 is 10. And negative 4 times 5 halves, negative 4 times 5 is negative 20, divided by 2 is negative 10. And I have 5 times 5, and negative 4 times 1, minus 4. Will this give us our identity matrix? I have 1, 0, 0, 1, yes. Okay guys, so that covers part of section 4.5. The next video will deal with 3 by 3 matrices and their inverses. Have a good day.